Every single minute, a garbage truck's worth of plastic waste is dumped into our oceans, clogging waterways, strangling sea life, and haunting our future. The problem feels overwhelming, nearly eternal. But in a quiet recycling plant in Japan, something extraordinary happened. Scientists noticed a humble patch of bacteria chewing through a water bottle as if it were nothing but a little breakfast snack. This isn't science fiction. It's the power of nature at work. Today, you're about to meet 7 natural ingredients: microbes, fungi, enzymes, and even sunlight. Each one a hitman in nature's silent war on plastic. Stick around, because the third one may already be working on the cup in your hand. Let's start with a marvel unearthed in 2016, PTase enzymes. These microscopic scissors were discovered in a humble patch of leaf mold at a Japanese recycling plant. While most organisms treat PET, the plastic in your soda bottle, like a locked safe, PTase snips it apart with ease, breaking long chains into bite-sized pieces. French company Carbios turbocharged this natural solution, engineering PTase to work even faster. Their supercharged version can dissolve 90% of PTE from a t-shirt in just 10 hours at 70 degrees Celsius, turning old bottles back into their building blocks without the need for new fossil fuels. These enzymes are now at work in industrial compost piles, quietly converting plastic back into raw materials, giving us a glimpse of a circular future. But bacteria aren't the only members of nature's cleanup crew. Enter the mushroom mafia. Deep in the soils of Pakistan, researchers discovered 2 fungi, Aspergillus terreus and Angiodontium album, that see polypropylene, the stuff of food containers and fabrics, as a tasty snack. They do need a little help. A quick blast of UV light cracks open the plastic, making it easier for the fungi to dig in. Once inside, their enzymes start breaking down the plastic's tough structure. After just 3 months in the soil, these fungi had devoured 21% of the plastic's weight. It's proof that with the right invite, nature's cleanup crew can make short work of even our toughest trash. But what if one microbe isn't enough? Enter the bacterial consortia, the full block party. In the wild, plastic doesn't just attract one species. Mixed communities of Pseudomonas, Bacillus, and Rhodococcus gang up, forming slimy biofilms on plastic surfaces. Each member brings its own digestive tool. Some secrete acids, others break bonds, others still mop up the leftovers. The result? Polyethylene, PET, even stubborn polystyrene begin to break down. Field trials in microplastic hotspots show up to 30% weight loss in 6 months. It's a slow, steady process, but 100% natural. A reminder that nature works best when everyone brings a dish to the potluck. Now let's talk about a secret weapon, X32 Microbial Blend. A California startup distilled an entire ecosystem into a powder. The recipe is hush-hush, but it's a mix of soil microbes and hungry enzymes that attack polyolefins, PET, and nylon all at once. Sprinkle this blend onto shredded plastics in a warm, damp pile, and more than 90% of the material disappears in under 2 years. No need for fancy reactors or chemicals, just water, warmth, and the right microbes. Textile plants and city compost yards across the US and Europe are already testing this blend, and the results are promising. Less plastic, no toxic leftovers, and a process that mimics natural decay. There's another dynamic duo at work, cutinase and protease enzymes. Cutinase is what plants use to unzip their waxy skin, while protease is the familiar enzyme in your laundry detergent. When scientists at Edinburgh University paired them up, they discovered something remarkable. PLA bioplastic, a compostable material, vanished from backyard compost bins in just 2 weeks at 50 degrees Celsius. That means those compostable coffee cups and lids aren't just marketing hype. With the right enzymes, they really can melt away, leaving nothing but nutrient-rich compost behind. It's a small but crucial step toward making bioplastics live up to their promise. But you don't have to step into a lab to see nature's work in action. Out at sea, every drifting bottle is home to a living crust called the plastosphere. This biofilm hosts thousands of microbial species that ooze enzymes and acids, slowly carving pits and channels into the plastic. The process is slow, years, not days, but it's happening globally, everywhere plastics drift. Scientists estimate that these wild biofilms already erase a measurable slice of oceanic microplastics each year. It's a quiet, continuous battle, fought by invisible armies on the world's waves. Sometimes, nature's secret weapon is simplicity itself. Sunlight and heat, the original pre-treat. Leave polypropylene plastics outdoors and, within weeks, they become brittle and fractured. Those cracks are open invitations for fungi and bacteria to move in. In Indonesia, test landfills use basic solar kilns, essentially greenhouses filled with plastic waste, to precondition the plastic. After just 40 days, fungal enzymes have chewed through 18% of the mass. It's low-tech, affordable, and requires no special equipment, just a little sunshine and a lot of patience. If you're finding these breakthroughs as fascinating as I do, now's a great time to tap, like so others can discover some good news for a change. And if you want to keep up with weekly deep dives into solutions that could save our planet, be sure to subscribe. But let's pause for a reality check. Before we all start tossing plastic in the yard and waiting for miracles, it's important to remember, most of these natural solutions only work on specific plastics, under just the right conditions. Temperature, moisture, surface area, and time all matter. A PET water bottle buried deep in a cold landfill won't disappear overnight. But in controlled settings, industrial composters, textile plants, or warm, damp piles, these natural agents are already making a measurable dent in our plastic mountain. And the pace is picking up. So, there you have it, 7 natural ingredients, each quietly chewing, slicing, and dissolving their way through the global plastic crisis. From the laser-sharp precision of PTAs to the buffet binge of the X32 blend, nature has handed us a blueprint, and we're finally starting to read it. Maybe it's time to retire the myth that plastic lasts forever. Share this with someone who thinks the problem is hopeless, and show them the solutions already sprouting beneath our feet. And if you're hungry for more breakthroughs, hit that subscribe button. I'll see you in the next one.